Hello, good evening, everyone. Hello, good evening. Hi, hi, James Freaks. Good evening. Hello, hi, RCA. Hello. Okay, so 7 o'clock na. Let's start siguro around 7:01. Hello, Jano. Hi, good evening. Okay, we have no? We have a rainy weekend. Buti naka-attend kayo. Okay, so ang topic natin for tonight will be yung last part ng ng deep dive series natin. So it will be yung data link layer. Start na tayo. So 7:01 na. Let's see. Okay. Okay, so as I was saying, ito yung last kumbaga sub-module nung deep dive series natin. So we'll be discussing yung data link layer. Okay? So previously we've discussed yung transport layer tsaka yung network layer. Okay? So let's go into a review kung ano yung napag-usapan last time with yung network layer. Okay? So let's just go through it once again. So yung mga features, responsibilities ng network layer, in particular, we're talking about yung IP or yung Internet Protocol. We talked about yung how is it responsible for the communication between yung hosts, no? Mga different IP devices, right? And then as well as yung logical addressing. So we kind of opened up yung topic about IP addressing. However, hindi natin, kumbaga, pa na-discuss siya in depth. We have a dedicated webinar for that, which is yung next webinar dito. Okay, IP addressing and subnetting. We talked about routing and how is it related sa network layer, no? So routers, which are network layer devices, ang trabaho nila is to look at the IP header, okay, nung packets na dumadaan sa kanila and find yung best path papunta dun sa destination IP address na yun, no? Okay? So yun. And then we also talked about yung time to live feature, okay? DTL. So it prevents yung packets from being routed across the network, no? Infinitely. So in case magkaroon ng routing loop, which is yung nagkakos na ma-route yung packets in an infinite manner across the network, pwedeng ma-stop yung loop because yung time to live field, it will get decremented every time may dadaanan siyang router, no? And when it reaches yung zero na value, then hanggang doon na lang yung packet, no? Hindi na siya pwede ma-route further. Okay? Then we talk about yung fragmentation, and that revolved around yung topic ng MTU or maximum transmission unit. So in that topic, discuss natin how the packets get broken down into smaller pieces kung masyado silang malaki. Okay? Malaki in a sense na they go over yung supported MTU nung link or yung particular network segment na supposedly dadaanan nila, no? Pero hindi sila makatawid doon dahil nga hindi sila pasok doon sa MTU supported nung link na yun. We also touch on a little bit about yung quality of service, okay? Quality of service at layer 3. Okay, and then also yung ICMP, Internet Control Message Protocol, and its function with regard dun sa being, kumbaga yung parang supporting protocol siya to IP. So that includes yung error reporting, feedback, and testing capabilities. No? Okay? And then yung, we also discussed IPv6 as well. No? Na pag-usapan natin yun. IPv6, yung differences between sa kanila, primarily 32 bits versus 128 bits. And IPv6 was, kumbaga yung pinaka naging solution para labanan yung exhaustion ng IPv4. Okay? Alright, so here we are. We're going to discuss yung data link layer, alternatively known as layer 2. So, keep in mind, dun sa TCP/IP model natin, we have yung link layer, which is nandun yung data link layer tsaka yung physical compressed together. No? So, just, kumbaga, as a review lang dun sa terms. No? Keep in mind na yung difference sa OSI model tsaka yung TCP/IP model. And then yung PDU, or Protocol Data Unit na tawag sa layer 2 natin, data link is frames, okay? So when we say frames, that means we're in the context of data link layer or layer 2. So an example layer 2 protocol would be Ethernet, as what we've been discussing up until this point. And an example of yung device that operates at layer 2 will be a switch, okay? So we'll have a whole webinar talking about yung switching, basics of switching, no? After nung IP addressing subnetting webinar natin. Okay, so that's coming up as well. Okay, so this is what happens, no? So nanggaling tayo from yung usapan natin about transport layer, then to network layer. And so here it is, no? Yung again the picture how the data is passed along dun sa different layers, no? So it starts from yung application, yung pinakauna, which is hindi ko na sinama dito because we've discussed that already in previous webinars. But then we start with yung pinakauna, no? Oops, let me see if I can. So we start yung sa pinakauna dito, yung sa segments. So as we know, this is sa portion pa ng transport layer to, no? Just before it gets to IP. So nandito si IP, right? So here our example will be yung TCP. Okay, so we have a TCP segment here. It contains portion of data from the original data, no? Hinati niya na to. So it goes into IP, of course, dito sa network layer. And then IP will be responsible of packaging that into a IP packet, right? So it will include yung sarili niyang header, okay? With all the necessary information, okay? IP address, source, and destination, and a bunch of other stuff, right? Yung mga different fields ng IP header. But primarily, of course, yung source and destination IP address. And then once it is ready to be transmitted dun sa physical network, no? Okay. Here in this example, ang layer 2 protocol natin is Ethernet. So that means, of course, we have an Ethernet network. Connected tayo sa isang Ethernet network in this case. And then yung IP packet will then be further encapsulated into an Ethernet frame, no? So there will be an Ethernet header dito. Okay, so frames na siya pagdating dito sa point na to. Okay, so that's how it goes. Okay, so let's move on. Okay, dito pag-usapan naman natin yung responsibilities ng data link layer. Okay, so there's still a couple of them here to discuss, no? We have yung of course yung within a certain physical network segment. Okay, so pinag-usapan natin last time is yung yung communication between hosts, no? However, hosts are end to end, ba? So from computer to computer. Okay, ngayon yung IP was responsible for helping yung dalawang host na yun makapag-usap, makatawid across the network, across the internet, for example. Right? Pagdating sa data link layer, the data link layer is actually only involved dun sa individual network segments in between. Okay, so that could be multiple network segments in between, depending on how many hops away yung dalawang nag-uusap na computer, no? Right? So in between those hops, nandun yung individual network segments, right? Physical networks. So we have yung segment communication, okay? So as you've seen, yung data link layer, yung header, that will change on segment by segment basis, right? So kumbaga, it shows na yung scope lang ng data link layer would be on a certain particular segment or layer 2 segment, so to speak. Okay, and for that to happen, we need yung physical addressing, right? So sa physical addressing, we have yung ating layer 2 address, which is for the most part will be tinatawag natin na MAC address. Okay? Media Access Control Address. So we discussed that in the yung ating introduction webinar. Okay? It contains it's made up of 48 bits and ang mga characters niya are hexadecimal. Okay? And yung difference with yung IP, of course, is yung IP is generally written in decimal. No? Si MAC address will be in hexadecimal. So going back, we'll be discussing MTU again, but this time sa perspective ng nung data link layer, which is yun yung enforcing layer, no? Napag-usapan natin to dun sa network layer webinar na pwedeng ma-fragment ang isang IP packet just because hindi niya na-meet yung MTU, okay, for a certain physical network segment, no, sa isang link. And then we discussed na yung data link layer is the one enforcing that, no? Yung data link layer, let's say for example in an Ethernet link, meron siyang certain limit lang na pwedeng ma-carry na amount of data, no? So yung data na yon from the perspective of yung Ethernet will be yung IP packet and anything na bit-bit niya pa further, right? So that will include yung transport layer and the actual data. So we'll be discussing yung segmentation sa LAN. Okay, so this is primarily about VLANs or 802.1q VLANs. Okay, segmentation using yung VLAN natin. Okay, yung pag-uusapan. A lot of people say actually ito yung mga pinaka-favorite topic, no? So I guess there's something about keeping things organized and separate. So we'll see how that is possible later on. So we'll be talking about QoS, but this will be layer 2 QoS naman. Okay? And then last but not the least will be error detection. This will involve yung tinatawag natin na FCS or frame check sequence. And then yung tinatawag na CRC or cyclic redundancy check, no? So we'll discuss that in more detail later on, but primarily ang goal nito would be yung data integrity, okay, no, frames na tumatawid doon sa isang physical link. So it should be able to detect corruption of data, any problems, errors in dun sa transmission over the wire or over the physical medium, no? So because hindi naman pwedeng it's not expected na perfect lagi lahat, no, yung pagkakatransmit ng frame. No? There could be things that could go wrong, kumbaga, during the transmission. So, nakakatulong yung pagsagawa nitong error detection na to dun sa process na yun, no? Sa pag-transmit dun sa physical network segment. Okay, so yan yung overview ng lahat ng i-discuss natin. Okay. And let's go through yung next. Okay, so first one is yung network segment communication. No? So as you can see here, we have two hosts, host A and B. Okay, they belong to the same, kumbaga, LAN. Okay, same LAN dito sa network na to. And we have yung router natin dito. Okay, so magkaka-connect sila lahat. So, from a layer 2 perspective, okay, since para silang nasa isang LAN, isang local area network, magkakakitaan sila. Okay, supposedly, right? Magkakakitaan sila if they're part of the same local area network. Okay. So, between yung computers and routers, nandun yung ating network segment, no? You can also consider itong segment na to as yung ating pinaka-local network, as what I've been saying. No? So anything beyond yung router na to, okay, is a different network, right? So yung whatever that network is, beyond the router will have its own local network then. Okay? So in this case, ito, sarili nating local network to on one part of the network, one portion of the network to. Yung dotted lines denotes yung demarcation natin. Kung makikita nyo yan dito. Right? So, walang frame na pwedeng makalagpas beyond this point. Okay? So, routers actually break yung, they break and separate yung layer 2 boundaries natin. No? Okay? So, ito, hanggang dito lang yung layer 2 boundary natin. So, from a layer 2 perspective, ito lang yung mga magkakakitaan. Okay? Dito. So, yung frame header will include yung source and destination MAC address, as you can see here, destination MAC and source MAC. Okay? And yung if yung router breaks yung layer 2 networks natin, who connects them together? Right? So, there's a missing piece dun sa puzzle natin. Okay? So, that brings us dito sa ating modified visualization, no, ng network natin kanina. So, there was a switch hidden all along. Okay? So, actually, dyan lang talaga siya, of course. Di ko lang muna pinakita dun sa previous slide. So, itong area na to, as I was saying kanina, ba? I kept on saying, ito yung magiging layer 2 segment. Right? Ito yung magiging layer 2 segment. So, we do have yung different physical, kumbaga, dito, physical parts ng network, right? May cable dito and all that. But then, of course, ang magdudugtong-dugtong sa kanila lahat would be yung switch. Okay? So, lahat sila na-aggregate dito sa switch. Kasama, in fact, si router. Okay? Doon. Ganyan usually yung itsura, no? Sa LAN, no? There will be a switch in the middle, connected yung mga hosts, and then they all go up to a router as yung path nila palabas punta sa ibang network. Yun yung kumbaga parang pinaka-common na setup. So alternatively, we can call this a switch segment, no? Kasi nga there's a switch here that is connecting multiple devices together. You can also say that yung orange dito na segment, kumbaga, it's also a layer 2 segment, no? Only that it's a direct connection between yung dalawang routers, no? Wala nga lang switch in between, right? So, this is also very normal. Okay? Hindi naman kailangan laging may switch in between, no? So, router to router, pwede silang mag-connect sa isa't isa, diretso. Okay? So, it doesn't mean na hindi to layer 2 segment kasi in fact, right, pagka nagpadala ng traffic itong si router dito to the one on the right, kailangan pa rin niya i-frame yung packet, right? So that's still layer 2. Okay, so in that context, you can still say na this is, still some form of a layer 2 segment dito. Because para makatawid dito, kailangan maging, di ba, layer 2. Okay, so yung switches, they operate at layer 2. Okay? Yung mga devices na connected sa layer 2, switch segment na to, kumbaga, makikita sila lahat ng switch. Okay? So, yung switch na nasa gitna, makikita niya lahat ng mga devices na connected sa kanya. And then, yung mga devices ng mga to, but even yung router, okay, makikita nila yung MAC address ng isa't isa. Okay? So, if hindi nila alam yung MAC address ng isa't isa, okay, itong let's say host A, host B, and host C, how will they be able to send frames to each other, right? Although tatawid naman sila ng switch, but still kailangan nilang mabuo yung Ethernet frame bago sila makapag start sending dito sa segment na to, no? So, baliwala yon kung wala sila nung MAC address nung tinatry nila kausapin, right? For example, host A and host B. Kailangan alam ni host A itong 56CE na to. Okay? So, again, yung switch, kita niya lahat ng mga MAC address ng mga devices na connected sa kanya. So, kita niya yung MAC address ni host A, okay? So, itong 0EA4. Kita din niya si host B. Kita niya si router, okay? Kita ni switch yan lahat. Okay, so we go into yung physical addressing, which is yun yung burned-in address, okay, nung isang network interface, okay? Out of yung straight out of yung manufacturing yun. So yung LAN port mo or your NIC, network interface card, okay, for example, sa computer, sa PC, or sa laptop, okay, it will have its own physical address. Okay? So, as you can see here, pinakita ko dito yung separation ng logical at physical address, right? So again, ang IP addresses are logical addresses. No? So pwede itong i-configure, nababago yan, and all that. Okay? But generally speaking, itong MAC address, okay, so it's the physical address, nakaset na yan dun sa network interface mo ng computer mo. Okay? So yan yun. So yung multiple devices on the same physical link, okay, so let's say connected sila sa between the same physical link, no, or perhaps a switch segment, okay, yung katulad ng example natin kanina. As long as connected sila together from the data link layer perspective, they can uniquely identify themselves using yung MAC address. Okay? So, kung ito yung IP addresses, okay, they are identified by their IP addresses across a network. Kahit pa sabihin mong magkalayo yun, magkaiba sila ng network, no? Doon naman sa particular LAN, for example, they will be able to identify each other using yung MAC addresses. Okay? So, yung scope yung IP addresses, yung logical addressing is mas malawak compared doon sa scope yung physical addressing, no? Yung MAC addresses natin. Particular lang siya sa isang layer 2 segment or even a physical segment, right? Okay, so we have yung anatomy of a MAC address. So as I've said, it's made up of 48 bits, hexadecimal characters. Okay, so each group dito is made up of 8 bits, 4 bits per character. So, paano na-achieve yung 4 bits per character is since hexadecimal siya, we need 16 total possible values, right? So, 0 to 9, and to represent yung 10 to 15, we have yung A to F, okay? Yung letters na A to F, okay? So, technically speaking, 0 to 15, we have a total of 16 total possible values. And paano natin ma-achieve yun using yung binary? Okay? So, ito yung pinaka-raw form niya. Okay? So, bago siya maging decimal, underneath that, it's actually a binary number. So to achieve that, we have we have 4 bits, no? So 4 bits, that is because 2 raised to 4 is equals to 16, right? And if we add up everything dito sa 4 bits na to, right? So we have 8 plus 4 plus 2 plus 1, right? So 8 plus 4, 12, plus 2, 14, plus 1, 15. Okay? So 0 to 15. Okay? So pag all zeros yan, 0. Pag all ones yan, then 15. Okay? So that represents yung 0 to 15 na hexadecimal digit natin dito. Hexadecimal character. Okay, so as we have here as an example, ang bits na naka-on is 8 tsaka 2, so that would be 10, and 10 here is actually A. So ito yun, ito yung single character na to, so A siya, so it represents 10, so in binary, 1, 0, 1, 0 siya, okay, because it's 8 plus 2. Okay, so yun. Right, so we go into yung tinatawag natin na broadcast address. Okay, so medyo na-open up na natin itong topic na to dun sa IP, tawag dito, network layer and internet protocol discussion natin. We talked about yung broadcast communication dun sa webinar na yun, no? So yung broadcast communication is very common sa data link layer, no? Or layer 2. We also talk about yung certain communication types may have yung certain addresses na kinakailangan gamitin. No? So in broadcast communication, layer 2 broadcast, okay? So layer 2 broadcast, ang address will be all Fs. Okay? So as you can see here, destination MAC niya is lahat F. Okay? So meaning, pag convert mo lahat yan sa binary, right? Remember, that would be yung 15. Okay? So if we go back dito, yan, 15, right? So paano magiging 15 yan? Ibig sabihin dapat 1 lahat to. Okay? So 8 plus 4 plus 2 plus 1 para maging 15. So broadcast addresses are always all ones. Okay? Okay, yung pinaka-general okay? So na broadcast address, okay? So there will be a distinction about yung mga broadcast addresses later on sa pagdating natin dun sa IP addressing. But in this case, sa layer 2, ito yung broadcast, no? Nakikita nyo. So all Fs. Okay? So pag nag-send ka ng isang broadcast frame sa isang particular layer 2 segment, okay? Lahat ng devices na nandun sa part ng LAN na yon, particular layer 2 segment na yon, okay? Ma-receive nila yon. Okay? So as long as they are part of the same local area network, okay, connected sila sa the same LAN, pag may nag-send na isa ng broadcast, ma-receive yun ng lahat. Okay? So yun yung purpose ng broadcast. So there are certain situations that this can happen. So for example, if a computer knows yung IP address of another computer and it wants to communicate with that computer, okay, but doesn't know yung MAC address, hindi niya alam yung MAC address nun. Pwede siya mag-send ng broadcast asking everyone kung sino yung IP address na yun. And when, kapag na-receive siya ng owner ng IP address na yun, pwede siya mag-respond back with its MAC address. Okay? So ito yung actually tinatawag na ARP or Address Resolution Protocol. Discuss natin yan pagdating dun sa Basics of Switching webinar natin. Okay? Alright, so that's it. Let's take a break for questions. Muna. Questions muna tayo. So on the chat, may humabol pa si NCTV. Okay. Hi, good evening. Si Carl. Good evening, Carl. Any questions? Questions, anyone so far? Okay, may question tayo from James Freaks. Sir, kung all ones ang broadcast address, ano naman po yung gamit ng all zeros na MAC? Well, wala siyang ano, no? Wala siyang particular na kumbaga special purpose. Okay? So, I don't think you'll see MAC addresses na all zeros, no? Yung all ones lang yung may special meaning. So pag nakakita kayo ng let's say yung the usual lang na MAC address, right? So ganyan naman yan usually. Meron siyang 12 hexadecimal characters, no? So each one of them represents 4 bits. So 48 bits in total. Siguro pag nakakita ka nun ng all zeros, medyo medyo suspicious yun. 'Di ba? Kasi if you think of it, yung mga gumagawa ng mga network interface card, yung mga gumagawa ng mga hardware for network devices, for example. Pare, yung computer mo lang, yung laptop mo, di ba? May NIC yan, di ba? May network interface card yan. Or even, let's say, yung wireless card niya, di ba? For your laptops. Okay? So, lahat ng mga yan, may kanya-kanya silang manufacturer, di ba? So, yung mga manufacturer na to, they're actually assigned a certain hexadecimal character. Okay? So, yung first couple of hexadecimal characters sa isang MAC address is actually assigned sa isang manufacturer. Okay? So, that is, kumbaga, dinidistribute sa mga manufacturer and then sila na bahala doon sa yung the other part, other half nung mga hexadecimal characters. So yun yung doon sila gagalaw sa ano na yun, sa the other half nung mga address. So if you, let's say for example, you look up yung isang certain MAC address, you can identify actually kung sino yung manufacturer na. Okay? So, I'm not sure kung sino yung may-ari ng 000000 na MAC address na manufacturer. Pero yeah, it's quite unlikely na makita mo siya. Okay? Ang may special meaning lang, remember, is yung all ones. Okay? So, all Fs. Basically, yung kalalabasan. Hi, Arvin. Good evening. Okay. Any other questions? Yeah, you're welcome, James Fix. May question ba? Otherwise, ano na lang siguro, buffer nyo na lang for later. May ano pa tayo, another question and answer part dun sa huli. Okay? So, let's proceed muna in the meantime. Alright. So, we have our discussion for MTU. No? So, we've touched on this topic dun sa naunang webinar, maximum transmission unit. Right? So when we discuss yung sa network layer, okay, previously, we talk about how the MTU nung link, okay? So let's say ito affects yung yung IP, which can lead to fragmentation. So yung data link layer, okay, primarily whatever it is yung framing nitong na to, particular physical segment na to, will be responsible for enforcing yung MTU, okay, through yung data link layer. Okay, so ito, whatever physical network segment this is whatever technology it is, for example, Ethernet, okay? So yung underlying framing neto will have a certain MTU. Alright? So yung sa data link layer, siya yung mag-enforce, okay, based dun nga sa underlying frame format ng physical network. I'm not talking about in physical media, like let's say copper, fiber, or wireless. Okay, I'm talking about yung framing protocol that runs over it, which siya yung nagdidictate nung data link frames natin. Okay? So for example, Ethernet. Okay? So to make this more clear, we can run yung Ethernet over yung copper cable or fiber cable. Okay? So to make that distinction, right? Between yung physical medium. Iba yun. Yung physical medium is yung actual klase nung wire. For example, yung copper, yung cable ba is made of copper or yung cable is made of fiber, no? So there are different types of Ethernet standards, no? The Ethernet technology. So each type generally follows a standard Ethernet framing format, okay? Pero meron silang mga unique framing techniques of their own. So to better understand, let me give a simple example, okay? Para lang makita nyo. Okay, so yung example natin, let's say yung lower speed Ethernet, like yung fast Ethernet, okay? But I know that doesn't make sense kasi kaya nga fast Ethernet, di ba? But fast Ethernet is actually 100 Mbps, okay? So typically, MTU niyan would be 1500 bytes. Okay? So yan yung may enforce. Okay? So kaya lang bitbitin ni fast Ethernet will be 1500 bytes. Okay? So this will include na yung IP header, yung transport layer protocol, so that could be TCP or UDP, plus yung data. Okay? Actual data na bitbit nila. Okay, so yung maximum nun would be, hindi pwede mag-exceed ng 1500 bytes. Yun yung ibig sabihin doon. Okay? So yung higher speed Ethernet like gigabit Ethernet and 10 gigabit Ethernet, makikita nyo, it can support 9,000 bytes. Okay? Okay, so those are yung tinatawag nating jumbo frames. Okay? And how that gets enforced is nandito sa yung Ethernet frame natin. So, discuss ko lang dito siguro yung mga most of the important dito of yung fields. So, we have yung the usual destination and source MAC address, right? And then we have yung ether type. Okay, so yung ether type is actually pertaining to kung ano yung protocol na dala niya. Okay, ano yung bitbit niya dito sa data part or data field ng Ethernet frame. Ito yung bitbit niya. Okay? So whatever is in here, okay, usually yung kasunod niya, which is yung IP, yun yung madidescribe dito sa ether type. No? So FYI lang, 0800 actually means bitbit niyang protocol is IP. Okay? So ayan, nakikita niyo yung IP, right? But then behind IP could be anything, right? TCP, UDP, and all that. And then we have yung CRC checksum dito, which is actually ang tawag sa field dito is yung frame check sequence, yung binanggit ko kanina, yung FCS. Okay? So we'll discuss that later on sa pinaka-last. The thing that I want you to focus here sa sa picture na to, would be itong payload part, no? So as you can see here, ito yung data portion. Whatever is in here is yun yung bit ni Ethernet, okay? So from perspective ni Ethernet, this is all data, okay? Whatever it is na nandito. Okay, so that includes, syempre mauna na dyan yung IP and whatever is yung nasa, yung bit ni IP, which could be TCP, UDP, or something else, diba? Now, the point here is, kailangan 1500 bytes siya maximum. Okay? So, like I said, dapat IP and everything na bit ni IP kasama na dyan, kailangan 1500 bytes siya. Okay? Pag nag-exceed dyan, yun na, mag-start, kailangan na fragmentation. Okay? So, dun yung sinasabi ko na si IP is mag-start siya mag-fragmentation kapag hindi niya na-meet tong 1500 bytes na to, for example. Okay? So, hindi siya kakasya kasi dito pag more than 1500 bytes siya. So, ang mangyayari, kailangan ma-break up ng original IP packet na yun. So, magmo-multiple IP packet siya. Okay? So, yun. So, each one will then go into an Ethernet frame. na mayroon lang maximum carrying capacity na 1500 bytes. Okay? So yun siya. Ganun yung concept nun. Okay, so let's go into yung tinatawag natin na VLANs or yung virtual LANs. Okay, so alam na natin kung ano yung LAN, di ba? Yung local area network. Pinag-usapan na natin yan in the past few webinars, right? But we have something that is called yung virtual LAN. Okay, so goal dito, yung target dito is ma-virtualize natin yung physical network natin. Okay? Ano bang ibig sabihin nun? Virtualize na yan. So, medyo parang fancy term siya, no? Ibig sabihin lang nun is, pwede natin i-slice, no? Hati-hatiin or i-segment yung ating physical network, no? So, let's say meron kang isang switch, for example, no? That doon nakakonect lahat yung um, tawag dito, yung mga computers. So, yung isang switch na yan, pwede mo actually hati-hatiin yun into multiple parang sort of virtual LANs, no? So, originally, kung wala namang, hindi ka gumagamit ng VLANs, parang iisang LAN lang, okay? Isang local area network ng lahat ng PC mo or lahat ng computers mo nakakabit dun sa switch, right? So, walang any kind of segmentation or virtualizing of the physical network na nangyari, no? But with VLANs, it is possible, no? Pwede yun, pwede mo hati-hatiin yun. Okay? Pwede ka mag-assign ng, ng isang or dalawang computer sa isang VLAN, and then on another VLAN, may tatlong computer, so on and so forth. Okay? So, a-assign mo lang yung different ports nung switch to a certain VLAN. Okay? The other aspect of that is yung, let's say, sa isang link, which is what we have here dito sa ano natin, visual natin is, let's say, ito yung link, right? Ito yung physical cable. Okay? So, yung mga tumatawid na traffic dyan, kung hindi ka gumagamit ng VLANs, they all belong to, parang parang wala silang distinction between each other. No? They all belong to a certain local area network. Okay? So in this case, ang pwede natin gawin is gumamit ng VLANs. Okay, i-assign yung kumbaga i-group natin yung different computers into certain VLANs, and then pagka tumatawid yung traffic nila dun sa links, okay, tumatawid sila papunta let's say to another switch, they will all be categorized or grouped into a certain VLAN. Okay? So, pwede natin mahati-hati or ma-segment yung traffic natin into yung, let's say, in different departments. Ito yung software engineering, yung accounting, yung customer service, okay? So, mayroong distinction between yung mga traffic na tumatawid dun sa link, no? So, hindi sila maghahalo-halo lang, kumbaga. So, kung walang VLAN, halo-halo lang sila dun. Okay? So, pagdating doon sa kabilang switch, no, yung the other side of this link, for example, ma-identify niya kung yung frame na yon na na-receive niya is part of a certain VLAN. Okay? So, how is this possible? Paano maging posible yung ganitong technology, no? So, this is possible through yung tinatawag nating 802.1q. Okay? Na tawag dito? Na tag. Okay? So, it's actually a tag na ini-insert din sa frame. Okay? So, maliit lang siya. Ito to that one Q tag. Okay? So, ang kinikerry nun is yung tinatawag na VLAN ID. Okay? So, yung VLAN ID is just a number. Okay? So, yun. So, ang mangyayari is yung kada frame, okay, as long as meron sila nung 802.1q tag nila, they could be identified between or amongst each other, right? So let's say yung software engineering mo has a VLAN ID of 100, accounting department has a VLAN ID of 200, and customer service has a VLAN ID of 300. Okay? So, tumawid-tawid man sila doon sa different switches mo, they maintain yung grouping nila, no? They are still considered as separate traffic. Okay? Yung grouping, yung pagkaka-segment nila between each other, because meron ngang 802.1 queue tag. Pag tinanggal mo yan, wala na, hindi mo na ma-identify yung frame na yon, right? Okay? And of course, syempre may scope lang naman yun. Hindi naman all throughout the network is merong VLAN tag. Okay? And necessary lang to between mga trunks. Okay? Which we'll be discussing pagdating dun sa basics of switching natin. But right now, this is all you need to understand. Okay? Na this is possible through yung tinatawag natin na 802.1q tag. Okay? So yun. So thanks to yung 802.1q tag, pwede natin ma-group yung different traffic natin, different types of traffic natin. So one distinction siguro before I proceed with the next slide is yung as you can see, yung VLAN ay yung 802.1q tag, in-insert lang siya sa gitna. Okay? So hindi siya encapsulation. Okay? Yun yung siguro gusto kong maisip niyo na distinction doon. So hindi siya, it's not an encapsulation by itself, no? It's just a something that gets inserted doon sa frame. It's a shim, kumbaga. Parang pinasok lang siya dyan, in-insert lang siya. Alright? So yun, so makikita natin dito sa, ito, yung physical link natin dito, virtually speaking, mga tumatawag dito na traffic, since they're tagged with yung VLAN ID nila, let's say ito 100, 200, 300, right? Sa paningin ng mga devices, they are separate traffic. Okay? So, ganun yun. May, kumbaga, they can be organized into different groups. So, ang point nito is, you can apply, different things. No? You can do certain things to a certain VLAN only. Okay? So, yun yung power nun, nung 802.1q VLANs. Okay? So, pwede ka mag-apply, let's say, pwede mo padaanin sa isang part lang ng network yung VLAN 300, okay? And everything else is bawal doon. Okay? So, pwede yun, for example. Right? Example lang yun. Example, parang real-world example. So, another thing that we have is yung tinatawag na 802.1p. And this touches on yung sinabi ko kanina na quality of service. Okay? So, yung quality of service, right? So, we had that in yung network layer natin. But in this case, yung sa layer 2, data link layer, we also have a way to perform quality of service, no? And that is possible through yung 802.1p. So, yung 802.1p is kasama siya dun sa 802.1q tag, okay? So, nakasabit siya dun, kumbaga. So, kung may 802.1q tag, ibig sabihin, it's possible to perform quality of service. Kasi, merong 802.1p field, which is actually yung priority field. Okay? So, again, yung quality of service, we are able to perform prioritization. Okay? So, aside from grouping them together, yung mga different types of traffic natin, let's say software engineering, accounting, customer service, okay, we can also apply priority sa kanila. So, kung makikita nyo dito, for example, yung software engineering, binigyan natin sila ng priority 4, so medyo mataas yung priority nila. Si accounting, binigyan natin ng priority 3. Si customer service, binigyan natin ng priority 2. Okay? So, comes congestion, okay? Pinakamauuna lagi, may bigyan ng priority is software engineering kasi siya yung highest priority, right? Next to it would be accounting and next to it would be customer service, okay? So, just for example lang yon, okay? So, yun yung point niya. So, kung may VLANs ka, you're using 802.1q tags, it's also an opportunity to perform prioritization, okay? And you can mark yung priority na yun dun sa 802.1q tags mo, okay? Sa mga VLANs mo. Okay, so I think yan na yung tawag dito. That's it for yung VLANs portion, okay? So kasama yung QoS dun sa VLAN. We now going to yung topic ng time to live pagdating sa layer 2, which is actually wala. Okay? So, yun lang actually gusto ko sabihin dito. Because this is something na very important or something to caution about. Sa layer 2 kasi, wala tayong time to live, no? So, yung time to live, it only exists dun sa layer 3. Okay? So, yung IP header. Okay? Yung IP header may yung time to live field. Sa layer 2, wala tayong time to live. Okay? Yung Ethernet frame, it doesn't include any time to live field. Okay? So, ito yung delikado, right? Pagdating sa layer 2 networks. Okay? So, pag meron kang switched network, okay? Switch dito, switch environment, there's a possibility na mag-loop yung mga frames, okay? So remember, frames siya, okay? Nasa layer 2 perspective tayo, okay? Hindi packets ang pinag-uusapan natin, okay? So habang tumatawid siya sa isang layer 2 segment, okay? Sa isang switch network, okay? Wala pa siya sa router, no? Okay? So remember, hindi pa siya or probably hindi nga siya destined sa isang no, the other side of the network, right? Nandun lang siya sa loob ng LAN, okay? So kadalasan pwede magkaroon ng issue within the LAN just because walang time to live field sa Ethernet header, no? Sa frame. Okay? So nagkaroon ng loop dito, issue yun, delikado yun. Mag-iikot-ikot siya. So nangyayari yun kasi meron ka mga multiple switches. Okay? And they're all they have redundant links between each other, no? So, remember yung broadcast, okay? Ang behavior ng broadcast is, di ba? Flood out all ports except kung saan siya nanggaling. So, remember kung meron ka pang isang switch dito, tas dalawa yung link nila sa isa't isa. Pumasok yung broadcast doon sa taas at mapa-flood siya sa lahat. Kasi ibig sabihin kasama yung sa nasa baba. Okay? So, iikot siya. So, imagine yung damage nun pag hindi na-prevent yun. Okay? So, yun. So, yun. Walang time to live sa, sa layer 2. Okay? Okay, so we have yung tinatawag natin na frame check sequence. Okay, so ito yung field sa dulo. Okay? So, in fact, ang tawag sa kanya is trailer. So, imbis na header, right? Meron tayong trailer kasi nasa dulo siya. Okay? So it's part of yung encapsulation process, obviously. The only difference is nandun siya sa huli. Okay? So, itong frame check sequence na to, so it's a trailer, imbes na header siya. Okay? So keep that in mind. Ang laman niya is yung CRC or yung tinatawag nating cyclic redundancy check. Okay? So, ang cyclic redundancy check or yung CRC is a algorithm na niraran para makapag-detect ng errors. Okay? So, errors in transmitting yung frame across the wire, no? Or across the physical medium. So, in case yung frame gets corrupted while in transit, okay? Pwede ma-check sa kabila kung yung integrity ng frame, no? Kung buo pa ba siya. Is it it's still kumbaga complete, no? Wala bang errors, wala bang lost na bits. Okay? So remember, things can go wrong, no, across the network pag na-transmit siya. So ang example nito is let's say si host A, di ba? May sisend siya kay switch, right? So kailangan mo na dumating kay switch. Pag tumawid siya dito, okay? So tumawid siya dun sa across the wire, di ba? So hindi siya pwedeng makalusot doon kung let's say pag run ni switch ng cyclic redundancy check is hindi nag-match yung CRC result na nandun sa FCS field. Okay? So, pagkukumparahin niya yon kung ano yung nasa FCS field tsaka yung sarili niyang cyclic redundancy check results, no? So, yung result ni host A, okay, tsaka yung result ni switch is dapat magkapareho, magkatugma. Okay? So yun. It's an integrity check. So pagka nagpapadala ka ng data across a wire, there should be a means para ma-check nung kabala na buo pa or tama pa yung na-receive niyang data, no? Hindi siya corrupted or anything like that, no? Or hindi kulang yung bits or let's say may mga nabago na bits, no? Imbis na 0, naging 1, or yung 1 naging 0, and all that. Who knows? Things can go wrong. Okay? Kumbaga, yun yung point nun. So, integrity check siya. Okay? Or possibly na modify yung frame, no? For whatever reason. So, ang point is, kailangan accurate pa rin siya pagkatawid niya. Okay? So, from one point to another. Okay, so actually tapos na yung discussion natin. Medyo maiksi lang yung pagdating sa data link layer. However, meron pa tayong lab demo, no? So let's just wrap up by discussing yung how the data link layer interacts with the higher and lower layers, no? So alam na naman natin, actually medyo na-discuss na natin kanina, kahit pa paano, at least yung sa higher part. But in this case, we'll discuss yung upper and lower layers from the perspective ng data link layer. So si data link layer, as we know, receives yung IP packets from the network layer, right? So pinapasa sa kanya ni network layer yon. So it encapsulates yung packets into frames, okay? It attaches yung kanyang sariling yung layer 2 header niya, okay? So kumbaga meron kang Ethernet header, for example, sa Ethernet. And also sa Ethernet, meron ding frame check sequence na trailer, right? So kasama yon. So once the frame is prepared, okay, at ready na siya for transmission across dun sa physical medium, yun, pwede siya ma-transmit, okay? Dun sa physical layer na. So, yung the other way around, obviously, is pag na-receive sa kabila, yung yung bits, no, coming from the physical medium, let's say sa wire, no, yung physical bits doon, yung signals, it gets put back together again into yung original frame. And then of course yung pagbasa ng frame, and then i-decapsulate siya, and then ipasa pataas sa network layer yung IP packet na laman ng frame, no. Ganyan. All right, so that's it. Let's go into our lab demo. So I have prepared a lab demo here. Let me just discuss ko lang yung natin. Yung diagram natin. So I'll share it doon sa chat para ma-open nyo din siya on your own window. So yan siya. And also, I'll pull it up dito sa screen ko. I'll discuss it first before we proceed doon sa aking console. Okay. So we have yung ating topology dito, yung diagram natin for our lab demo. So what we have is we have one switch, okay? And then we have two servers. Okay? So simple lang gagawin natin. So we have one switch, two servers, okay? So yung isang server is 10.10.1.1. And then yung isang server is 10.10.1.2. Okay? So yun yung IP addresses nila. And so si 10.10.1.1 siya si serve 11, connected siya kay XE001 na port doon sa switch. Okay? So doon siya nakakabit. Okay? So si serve 12, which is si 10.10.1.2, nakakabit siya kay XE002 na port. Okay? Doon sa switch. And then they're supposed to be part of the same VLAN. Okay? So yun yung magiging goal natin. Ang goal natin is i-configure itong dalawang port na to, yung XE001 at XE002, para yung dalawang server will be part of the same VLAN para magkita sila. Okay? So, pwede sila mag-usap. Makapag-communicate sila sa isa't isa. Okay? So, that's our goal. Let me switch to my console. Let's start dun sa ating lab demo. Okay? So, yun. So, we have yung, let's see, yung ating, let me see, show interfaces. Okay, so we have yung XE001 and we have yung XE002. Okay, so currently meron silang existing config. Okay, so kailangan natin burahin yan. Okay, so let's go for ano muna, si XE001, which is si serve11, right? So configure natin siya. Uh, Success, okay. So let's put it in VLAN 10. Okay? So remember, ito yung VLAN ID niya. Okay? So since nasa VLAN 10 siya, yung ano niya, yung si Serve11 na to, dapat makikita niya is whoever is in the same VLAN as well. Okay? So hindi pwede magkita yung dalawang computer, for example, in this case, may dalawa tayong server na nakakabit sa switch, hindi sila pwede magkita kung magkaiba sila ng VLAN. Okay? So, kung magkasama lang sila sa VLAN, yun yung way para magkita sila. Okay? By default. Alright? Okay? So, from technically speaking, pwede sila magkita pero kakailanganin ng routing. Okay? But we won't get into that yet. So, in this case, gusto lang natin pagkitain yung dalawa within the same LAN. Okay? The same VLAN. Okay? So, kailangan natin i-configure yung VLAN as well. Okay? So, yung VLAN is kino-configure. Then, kailangan natin i-set yan. Now, we have yung config natin. So, tama to. Tanggal yan. And then, let's configure yung XE001, right? So, we put it in VLAN 10. Okay? And then, we also created yung corresponding yung VLAN 10. Okay? So, commit natin yan. Let's hop on to yung ating serve11. Yan. Confirm lang natin yung IP address niya. 10.10.1.1. Okay? And also serve12 10.10.1.2. Okay? So ano naman sila, magka same network naman sila. Now the only thing for us to do is to put them into the same VLAN as well para magkita din sila. Okay? Doon sa LAN. Okay? So yun. So right now ang naka-configure pa lang natin is si XE001. Okay? So, it's part of yung server 10 or yung VLAN 10. Okay? As you can see here, binigyan natin ng pangalan yung VLAN. No? Pangalan ng VLAN is yung server 10. Okay? So, this is just a logical name. But technically speaking, this is VLAN 10. Okay? So, makita nyo dito yung tag. Okay? So, 10 siya. Right? So, whatever is yung VLAN ID. Okay? So, yun yung tag. Ito yung tag dito. Magagamit if in case kailangan siyang lagyan ng 802.1q tag. Okay? So, yun. So, we have Ngayon, hindi pa natin nakikita yung MAC address, right? So remember, ang switch nakikita niya dapat lahat ng connected sa kanya. So the reason wala pa tong nakikita MAC address, yung switch natin, is hindi pa naman nag-initiate ng traffic si Server 11. So let's go ahead and do that right now. Okay. And let's try to ping yung Server 12. Okay. Which we know na hindi pa naman niya ma-reach kasi hindi pa naman sila nasa same VLAN, right? And sure enough, destination host unreachable pa siya. Okay? So, we wanna check dun sa switch kung nakita niya yung MAC address kasi may nag-initiate na naman ng traffic. So dapat meron na siya. So, there you go. Okay? So, kung naka-receive siya ng traffic from XE001, okay? And dito yung MAC address nun. If we validate that, 9269, okay? So, that would be si Ethernet 1 ng Server 11, 9269, right? So, nakita niya na. Okay, so kita niya si Server 11 from a layer 2 perspective. Kabilang siya sa Server 10. Okay? Nare-receive siya from yung XE001 port. Which obviously because doon nakakabit si Server 11 at kinonfigure natin to. Okay? So, that all makes sense now. One thing that I also want to show you first bago natin i-configure si Server 12 is yung nabanggit ko kanina na ARP or Address Resolution Protocol. So although hindi pa natin ito na-discuss right now, gusto ko lang pakita sa inyo. Okay? So nabanggit ko kanina na let's say for example, alam ni computer yung IP address 10.10.1.2 pero hindi pa niya alam yung MAC address. Okay? So missing information pa to. Okay? So hindi pa makakapag-send si Server 11 kay Server 12 kung wala pa tong MAC address na to. Okay? So yun muna yung gusto kong pakita sa inyo as a pre-check. Later on, dapat makuha niyan yung MAC address ni Server 12. Okay? Once na na-assign na natin si Server 12 on the same VLAN. Okay? So they should be able to reach each other. Kasi ang mangyayari, magpapadala ng broadcast si Server 11. And yung broadcast na yun, makakatawid lang yun kay Server 12 if they are on the same VLAN. Okay? So let's go ahead and do that right now. Let's see. Hindi, sige. Okay, configure natin siya as access. Okay, and I think hindi ko pa na bura yung existing feed niya. Alright, so here we have our config. Review lang natin. So tanggal yung existing config and then we configure the port sa VLAN 10. Okay? So VLAN 10 already exists. Hindi na natin kailangan configure ulit. Assign na lang natin mag-assign na lang natin additional ports which is si XE002 dito sa VLAN na to. Okay? So gagawin lang natin siyang part ng VLAN 10. Okay? So that's it. And nag-succeed yun. So that means dapat okay na lahat. Okay? So pag pining natin to si server 12 from server 11, dapat mag-okay na to. Okay? So makita ko lang yung ARP cache ni server 12 para makita nyo wala pang entry ni 10.10.1.1. No? So remember, makakausap ni server 12 si server 11. So si server 11 is nasa 10.10.1.1. So magkakaroon niya ng entry dito mamaya. In the same way na mayroon si server 11. Pero si server 11, although nag-initiate siya ng traffic kanina to server 12, which is 10.10.1.2, incomplete pa siya kasi hindi pa sila nasa same VLAN. But now it's all done and complete yung VLAN configuration natin. Both XE001 and 002 are part of the same VLAN. So this should work. And sure enough, it works, right? So makikita natin, okay, stop ko na to. yung ARP dapat na complete. Okay? So as you can see, 10.10.1.2 is itong MAC address na to. So 95EA, let's validate that dito kay serve12. So sure enough, we have 95EA here. At pagka tingnan ulit natin yung ARP cache ni serve12, nakikita natin yung entry para kay serve11. Okay? 10.10.1.1, MAC address na 9269. Right? And if we go back doon sa switch natin, makikita natin dito na dapat kita na ni switch yung both na MAC addresses, no? Yan, di ba? Makikita natin dito si 95EA nandiyan na, which is si ano to? Si serve12, right? Si 95EA. Okay? And then si 9269, which is si serve11. So they're both seen in their respective interfaces, XE001 for serve11, XE002 for serve12. Okay? And they're both on the same VLAN, server 10, di ba? Server 10. Okay? So yun. And yun. So yung mga kinonfigure natin interfaces as a review, right? Makikita natin dito, we have yung dalawang interfaces, XE001 and XE002. Pareho silang member ng server 10 VLAN, and obviously they will if they will be tagged within a22.1q tag, it will be 10, right? For VLAN 10. Okay? So that's it. That's all for our lab demo actually. So yun lang yun for data link layer. So lahat ng pinag-usapan natin dito is from the perspective of data link layer, no? Layer 2. Okay? So puro layer 2 'tong mga topics natin yan. Dito, yung pinakita natin dito sa lab. Alright? So let's go to questions. Okay? Okay, so questions tayo. Any questions, anyone? May time pa tayo. Okay, so may question si Arvin Lee. Sir, regarding sa QS, lagi po bang higher priority ang P4? Okay. So, actually medyo advanced topic yung yung QS, but I really wanted to make it part of yung natin, yung tawag natin yung itong webinar series na to, no? But to give you an idea, technically speaking, okay? Yung pagdating sa QS, yung priority for, okay, or yung any other priority is just a marking. Okay? So it's like a parang it's like parang convention lang siya, okay? So whatever you do dun sa marking na yon is it can be different, okay? It can be different. So there's a certain distinction dun sa marking, okay? Yung marking nung packet or nung frame dun sa actual action mo. So kung anong gagawin mo dun sa marking na yun, no? So by practice, kumbaga parang standard practice, ang nangyayari lang is we just follow yung kumbaga yung kumbaga convention na the higher the better. Okay? So we have yung tinatawag natin na yun nga, yung 802.1p, right, which is priority bits. So we have, we have 3 bits doon, okay? So 2 raised to 3, if you compute that, katulad nung compute natin sa binary kanina, you end up with a total number of 8 possible values, no? So you have actually 0 to 7, okay, when it comes to priority. So you can have priority 0 all the way up to priority 7. Okay? May ganun, okay? So normally may ano lang, may parang kumbaga yung pagdating sa mga application, usually ano lang 0 to 5 lang 'yun. Okay? Yung 6 and 7 ginagamit 'yun for yung mga very important critical control type of traffic, no. When I say control traffic, 'yun yung mga usapan between yung mga switches and mga routers, okay? But let's say for example for normal applications lang, they can go within 0 to 5, no? As I said, parang standard convention. So let's say 5 is voice. Okay? So very sensitive si voice, kailangan mauna siya palagi. Hindi pwedeng ma-delay si voice, no? So latency sensitive siya. So typically pwedeng tawag dito, pwede mong gawing 5 si voice, okay? And let's say priority 4 is video. Okay? For example, pwede ganun. And everything else like internet traffic, mga best effort traffic, ano lang sila, 0 lang sila, ano, or no priority at all, no? Parang best effort lang. So normally ganun yung convention. But it doesn't prevent you to say na, let's say, minark ko si voice ng priority 4. Okay? Although si voice yung pinaka-priority ko, for example. Marking lang siya eh. Okay? Marking lang siya. But due to yung parang, ano na rin, parang standard practice na rin, standard convention, pina-follow na lang yung the higher the better. Okay? So normally, yung pinaka-highest sa mga applications, yung number 5. Okay? And then yung next highest would be 4. Okay? And then yung let's say, mga nasa gitna, mga 3, 2, 1, yun yung mga business critical applications, no? Yung mga important and traffic. And then the rest, yung 0, puro mga ano na yun, yung mga browsing, HTTP traffic, and HTTPS. Yung mga yung mga everything else, you know, yung mga garbage traffic, mga torrent. Mga ganun, okay? So, just bear in mind na the marking is totally separate on yung action, yung what you do with yung marking na yun, okay? Whether saan mo siya ilalagay sa prioritization mo. Okay? So yung priorities, okay, yung 802.1p na pinakita natin kanina, and also yung DSCP feed pagdating sa network layer naman sa IP header, they're just markings, no? Kumbaga parang tag lang din sila. Kumbaga yung concept ng VLAN kanina. Okay? So parang nilalagyan mo lang ng tag yung isang traffic to say na okay, ito yung tag na to. Pero pagdating sa, let's say, pag pumasok siya sa isang switch or pumasok siya sa isang router, nandun sa router na yun o sa switch na yun, depending sa kung paano siya kinonfigure, kung paano iti-treat yung marking na yun, no? So, I could say na, let's say, priority 1 is pinaka-priority sa lahat, no? walang tawag dito. Walang magagawa, kumbaga yung marking na yun, kahit ano pa yun, kung sabihin dun sa pagka-configure ng router na yun or yung switch na yun, na yung priority 1 is yung pinaka mapaprioritize. Or maybe even siya yung pinaka, for example, pwede ring in a way na siya yung pinaka mabibigyan nung most nung bandwidth, di ba? Pwede rin ganun. Okay? It could be done in so many ways, for example. But in terms of prioritization, yeah, it depends sa kung paano siya kinonfigure. Marking is totally separate thing. Any other question? Okay na ba yan, Arvin? Malinaw ba siya? I hope malinaw siya. Actually, medyo advanced topic na yan. But I wanted to give you guys an idea na merong ganun, okay? Because it's part of yung data link header, yung Ethernet frame, tsaka yung network layer header or yung IP header natin. Yes, yes, okay. Buti naman. Oh, buti naman. Mm. Parang ano 'yun, 'di ba, sa let's say sa ano, sa courier 'no, yung 'pag nag-FILBC ka, kahit lagyan mo ng fragile 'yun, it doesn't mean na it will be handled with care. So depende pa rin sa nag-i-implement. Okay. So I know medyo funny example 'yun, but it's true, 'di ba? It's true. Kahit sabi mo pang nakalagay do'n sa nakatag do'n sa package mo, do'n sa box mo is fragile, ano siya, package siya, handle with care. Hindi pa rin, eh, you're still at the mercy of kung sino yung nagha-handle, 'di ba? So gano'n. Any other questions sa topic natin? May time pa tayo actually. May extra minutes pa tayo. Medyo maaga tayo natapos. Okay, so kung wala ng question or maybe later after niyo ma-review uli yung ano, yung webinar na 'to, yung recording, okay? So don't hesitate. You can still shoot me an email if you have any question. Okay? So that's it for our data link layer. The last webinar for yung deep dive series natin. Okay? So as usual, okay? You can get in touch with me. Alam niyo naman yung email ko. And also get in touch with me with any of yung mga social media channels ko. And again, as always, yung feedback, I really appreciate yung lahat mga nagfi-feedback. Don't worry, binabasa ko lahat, no? I try to go through lahat ng mga feedback nyo and I take it seriously. So it helps me improve yung mga webinars. And yun, I'll see you sa susunod na webinar natin. That will be next Saturday again. So just stay tuned dun sa notification, mano-notify naman kayo. Okay, so same time naman as usual. And yeah, thank you. Thanks everyone for joining our webinar session for tonight. Okay? So yun, have a good night everyone. Thank you. Yeah, enjoy your weekends, no? Rainy weekends, however. So yan, ingat everyone. Okay? So yun, thank you. See you next time.